Hello, I'm going to be going through the Pythagorean identities section of the Unit 10 trigonometric functions. It is the last section, so you will be having a test in the next couple of days here. Probably do review and then test, so that will be coming out, just be aware. The Pythagorean identity, well, the first thing you need to know is what an identity is. So an identity is a mathematical statement that is always true. No matter what values are used for the variables. So that is probably the most paramount thing that you need to know, that an identity is true no matter what variables are in there. So if you say like 5 equals 5, that is true. Or if I say 5x equals 5x, it doesn't matter what number I plug in here and here, it's going to be the same. That's a really basic example of an identity. We're going to get into some trig identities now. And actually there's only one, and then you can derive all the other ones from it. So we are going to look at the Pythagorean identity. The first thing I want you to do is go ahead and cross off this section and this section, because this works. And you can actually cross off this second sentence here too. Because this works, but if it's called the Pythagorean identity, we're going to use the Pythagorean theorem to figure it out. So we're actually just going to be looking at this right here. So we already know that in a unit circle, the radius is 1, so this section of the circle right here is going to be 1. So I'm just going to draw out real quick what it would look like if we were to drop an altitude straight down here and make it a right angle. So it would look something like this. Okay, and we already know that this is going to be 1. So the coordinates of the point here are cosine theta, sine theta. We already know that as well. It's cosine sine. So if you're looking at this triangle, the distance that you're going over is your x value, which is actually cosine theta. The distance that you're going up is your y value, which is sine theta. And now the neat thing is, if you plug this into the Pythagorean theorem, which says a squared plus b squared equals c squared, well, we know that we have, in here, we have a, b, and c. So we're actually going to have cosine theta squared plus sine theta squared equals 1 squared. Which we already know, 1 squared is going to be just 1. And this gets rewritten as cosine squared theta plus sine squared theta equals 1. That is the single most important identity that you are going to learn in terms of trig. So if you can remember cosine squared theta plus sine squared equals 1, you can figure out all the rest of what we're doing here. For example, sometimes you will need it in terms of cosine. So if you subtract sine from both sides, you'll end up with cosine squared theta equals 1 minus sine squared theta. Or if you subtract cosine from both sides, you'll have sine squared theta equals 1 minus cosine squared theta. So these both come from that one. Just doing something to the sine, doing something to the cosine, and you end up with 2 more identities right here, which are always true. No matter what value you plug in for theta, it will work. So we're actually going to do that right now. I just picked a random number. I picked pi over 3. So the first thing you need to do is go from radians to degrees. So if we have pi over 3, to convert that, we multiply by, well, we want the pi's to cancel, so it's 180 over pi. So our pi's cancel. We end up with 180 over 3, which is 60 degrees. And now we're going to go ahead and plug 60 degrees in to our Pythagorean identity, which is cosine squared theta plus sine squared theta equals 1. So we're going to do cosine of 60, and I'm going to switch this back just to make it a little easier to understand, squared plus sine 60 squared equals 1. So if we put cosine 60 in parentheses and squared, and I'll give you a heads up that there will be another set of parentheses right here and right here in your calculator. Cosine of 60 squared gives you 0.25 plus sine of 60 squared gives you 0.75. And we know that a quarter and 3/4 is $1, so 1 equals 1. And now what I am saying is that no matter what number you picked here and plugged in, it will give you 1 equals 1 at the bottom. Because it's an identity. It's true no matter what variable you plug in. So what we're going to do now is we're going to use this original identity here, and we're going to derive the other two that you need to know. So from this identity, we can derive two other Pythagorean identities. The first one, if we divide everything by cosine squared, you'll have cosine squared plus sine squared, forgot my theta there, plus sine squared theta equals 1. So if we divide all this, divide each piece by cosine squared theta, well, this first piece here, cosine squared over cosine squared, is going to just give us 1. Plus, we know that sine over cosine is tangent, so this is going to be tan squared theta equals, and the final piece here, 1 over cosine, well, 1 over cosine matches up with secant, so that's secant squared theta. So our next identity is 1 plus tan squared theta equals secant squared theta. And just like the other piece, you can split this up into two additional ones. So if we subtract tangent from both sides, you'll have 1 equals secant squared theta minus tan squared theta. And instead of subtracting tangent, you could also subtract 1. So your other one would be tan squared theta equals secant squared theta minus 1. So now you have two other identities, which if you remember those, great. I forgot my n here, I just noticed. If you remember those, fantastic. If you don't, there's other ways to work around it. What I would like you to do now, and we will go over this in class, is I want you to go through and do the same thing, but instead of dividing by sine, I want you to divide by, or instead of dividing by cosine, I want you to divide by sine. So you're going to take cos squared theta plus sine squared theta equals 1, and I want you to divide each piece here by sine squared. And you should end up with 3 other identities. So you'll get your original, you'll do subtraction to get those other 2. We will go over that in class, but I'd like you to give it a try. I am going to walk around and check it tomorrow. If you don't have it done, we're going to have a problem. So give it a try. I understand you might make a mistake. That's fine, but you need to try it. The last thing that I want to go through together with you here is this problem. Write cotangent squared theta times 1 minus cos squared theta as a single function or constant. So what I would like you to do is first make a note. Write everything as sine and cosine. So what that means is take each of these pieces and write it as sines and cosines. So you have nothing else in there. So we have cotangent squared theta. Well, we know that this piece here, is going to be cosine squared theta over sine squared theta. And we're multiplying that by, well, 1 here, we know that 1 is sine squared theta plus cosine squared theta, because that equals 1. So this is going to be sine squared theta plus cos squared theta. And the last piece is just minus cos squared theta. So if you see what you have here now, looking at this piece, so we have cos squared over sine squared times sine plus cos minus cos. Well, if you notice right here, cos squared minus cos squared, those are just going to cancel out. So we have cos squared theta over sine squared theta times sine squared theta. And you could write that over 1 if you wanted to, but now you should be able to see that the sine and the sine are going to cancel, and we're left with just cosine squared theta, which is actually our final answer, because we have written it as a single function all by itself there. The next two examples, we're probably going to go over one of them in class. That last one, though, I don't know if we're even going to do it all, because it's really tough, and it's one multiple choice question, if that. If you would like to go over it and we don't do it in class, though, let me know and we can do it at some other point. So again, please make sure that you give this a try, divide by your sine squared there, and derive your other Pythagorean identities, and I will see you tomorrow. Have a wonderful night.